All right, guys, so let's go at it again. All right, so we wanted this question here. All right, so let's analyze it before we even go into it, right? First thing, it is not in the trigonometric form. Probably like 60% there, but not fully. Why these powers? Because the trigonometric form is just cos alone plus sine. Cos and sine. No sine cubes, cos squares. No. So right now this is not 100% in the trigonometric form. You can clearly see that. Right. Secondly, it's not in the exponential form, as I say, because it's not in exponentials and it's just cos and sines. Right. Lastly, we know we need to factorize the 2 pi out of these two, right? Because obviously that is what that will help us to get the spectrum. And that's just the correct thing to do, right? You don't really work with these things in here because you'll make silly mistakes because you'll forget to factorize it and you'll notice both of them have the same harmonic, right? Remember the F naught is the harmonic. That is why you need to factorize the 2 pi. Because remember the form of it is 2 pi k F naught T. You need that KF naught, but that is the harmonic form, but the 2 pi must be outside. Yeah, so just be careful, right? So nice. So let's get to this. So we need to find some way for us to get rid of this cos square and this sine square. Yeah, we need to get it into cos's and sines alone to get into the trigonometric form. All right, so let's go across to the whiteboard and get on to this. So let's use the same color. All right, so we have cos squared. Let's work with this piece. So let's factorize the 2 first. So cos square factorize the 2, so it'll be 2 pi 2 f naught t. Then you have plus sine square 2 pi, and that is 4 f naught t. Yeah. So now we need to get rid of the squares. All right, so to do that, we need to use compound angles. Right, my advice: make sure you memorize the compound angles. All right, because that is your best bet at getting rid of powers. All right, so your compound, how you just set it up? We have be using the cos form of it. All right, so how that will look? You have cos e plus e. All right, so that is e cos e and minus sine e sine e. All right, and then cos of e minus e be cos e, and then when it's minus is a plus sine e sine e. Right, so obviously see we could write this in a way that easier to see. Right, so this will be cos of 2a, right, is equal to cos squared e minus sine squared e, and then a minus e is 0, and cos of 0 is 1, right? That is equal to cos squared e plus sine squared e. Yeah? So we have these two equations here, right? And we could use them to get rid of our sine square and our cos square. That's very cool to remember, right? So let's start with the cos square. So if I want to get rid of the cos square, I need to make cos square the subject of the formula, right? So I need to get rid of this sine square to me. So a minus and a plus. If I want to get rid of our minus, I'll just add the two. So we adding two equations together. So on this side, you'll get plus 2a plus 1. This will give you a 2 cos square a, and minus plus something will disappear. So it's gone. So in this case, we could make cos square A the subject of the formula, and that would just be a half cos 2A plus a half. Yeah. Let's do it for the sines one time. Right. So if we're doing with the sine, we want the sines to stay. So we have to get rid of the cos squared. So to get rid of the cos squared, just subtract, right? So subtract for everything. Right. So if we subtract then that will end up being cos 2A minus 1, right? And as the cos's will disappear. And you'll get minus sine minus, so you get minus 2 sine square A. Right, and then make sine squared the subject of the formula. Right, so you end up with minus a half cos 2A plus a half. Right? And that's the first two. Very important. Two equations I really need to remember, right? This is where we use to get rid of a cos square. And this is where you could use to get rid of a sine square. And you notice they put it in terms of cos automatically. So you'll be going into the trigonometric form, which is what you want, right? And by extension, the harmonic form, right? The trigonometric form is piece of the harmonic form. Or you can say the harmonic form is piece of the trigonometric form. You can think of the harmonic form once it is all cos, like that's cos, 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 plus cos, plus cos. That is the harmonic form, right? So obviously the trigonometric form has cos's in it, but let's not worry about that as yet. For now, trying to get everything in terms of cos, right? So we'll get to questions with those sort of stuff eventually. Right, so let's get back to the question. So let's split it. So we know A, as I say, is just anything inside the bracket. So let's do it quickly. So we have f of t. All right, doing this first piece here, all right, so it'll be a half cos of 2 by 8. So we can just multiply that one time. So it'll be 2 pi, and then that will go to 4 f naught t. Okay, I had to multiply by 2. A is everything inside the bracket, right? So obviously we know the 2 pi will stay. So you can just multiply it by the harmonic. Right, so then it'll be plus a half. And then the second piece is what we have for the sine square, we have minus a half cos, so 2a. So we're multiplying it by 2 again. So that is this piece here. So it'll be 2 pi, and I get 8 f naught t, and then you have plus a half. Right. So now isn't our form that better? So let's simplify it. So the half and the half will give you 1. So end up with a half plus a 2 pi 4f naught t minus a half plus a 2 pi 8f naught t. Alright, so that's accounted for, this is accounted for, and the half will give you 1. Alright, so we have one small problem, right? Is that is a sum of sinusoids. Sum means you always add it, plus, right? So this positive, good, right? I think I forget the half. So it'll be 1, right? Yeah, so nice. So this is that, this is this, and the half will give you 1, right? So this minus here is a problem, a big problem, because it's a sum of sinusoid, meaning that everything have to be positive, have to be a sum of them. So we need to know what minus. So we know cos minus theta is equal to cos theta. Why? Because cos is a even function. So we need to know what minus cos theta is. Right? So this here, if you want to invert cos, you can either add 180 or subtract 180 from wherever it is. So you'll just add 180 to it. Right? If you're given trouble, you can check Desmos. Desmos has this. I'll show you that in a bit. Right? Probably at the end of the question. So that's how we could get rid of the minus. We will have to add basically to the face part of the question, right? So we could rewrite this f of t a half plus a 2 pi 4 f naught t, and this will be a plus a half, which is what we want. So it'll be 2 pi 8 f naught t, and we need to add 180. Or you can say pi and 2 if you want it. 2, right? And plus 1. Right, so nice. Everything is plus sum of sinusoids. It is in the trigonometric form. Right, anytime you have a constant, right, with no cosines or sines, that is called a DC components. Right, so we see now DC components surfacing here. Right, nice. So that is that. So what we need to do now is plot the spectrums. Actually, no, not yet. We need to get it in the exponential form, please. Right, so to get this into the exponential form, right? So we need to use cos theta is equal to e j theta plus e to the minus j theta. And I'm just going to write it half, just for simplicity, because it's going to be happening. So let's do that. All right, so for the first piece, all right, because it's a half, yeah, multiplying a half by half. Yeah, so that'll be a quarter. And that'll be e to j, and as I said, everything inside the brackets is theta. Right, so the positive part, and this will be plus a quarter e to the minus j 2 pi 4f naught t. Right, so add this piece. Then place second place is a quarter e to the j 2 pi 8 f naught t plus 180, and it'll be plus a quarter e to the minus j 2 pi 8 f naught t plus 180. Right. And then last piece, well, this is just one. Right. So in this case, it will just stay as is. Not really gonna change. Right, because you can only convert the cos theta to e. Right. So that just stay. That's two. Right. So as I said, we need to split. This one here need to split. Right. This one here have nothing to split. Could have a sum. So let's do that quick. A quarter e j 2 pi 4 f naught t, right? So plus a quarter e to the minus j 2 pi 4 f naught t. And then you have plus a quarter e to the j 2 pi 8 f naught t. And then you have multiply that by e to the j 180. Right, and I'll go on it plus a quarter e to the minus j 2 pi 8 f naught t, And then you have 1 divided by e to the j, yeah, minus 180. Right, so next, so now we finish with that now. We have the complex form and we have the trig form. So we could plot the spectrums now. So let's use screen. So we have the magnitude. So we'll start with the single side and we'll just use the shortcut to get the double-sided, right? Because we now know how to do that. So it'll be single-sided and double-sided spectrum. So we'll start with the single-sided. So for the single-sided, we go to the trigonometric form. So we have 4 f naughts and 8 f naughts. Right, so 4 f naughts, 8 f naughts, and magnitude, and you have frequency. So the magnitudes, add those, will be half, and a half, right? And we have 1. This one is the DC component, which is always at a frequency of 0, right? So that going up to 1, so let's use a different color, right? And that is a DC component, right? So 0, 4 f naught, 8 f naught. So now we can say ratch the double-sided, right? So we know for the double-sided, we go on mirror. So you get minus 4 f naught and minus 8 f naught. Right, and we know we go on half, and it will stay as is. So this will be a quarter and 1/4, right? And that's it. The DC component is centered at 0, so it will just stay constant, right? So, and if you look back at the exponential form, you can clearly see that the magnitudes were a quarter. Yeah, right. So then if you plot the phase, same idea. We'll plot the single-sided spectrum, and then we'll just use the ratchet to get the double-sided. So we'll start with the single. So we know it's 4 f naughts and 8 f naughts, right? So add those using the single, no, nothing at 4 f naught, and you have 180 at 8 f naught. So nothing here, and let's say I have 180, right? So that's labeled. So we know this is phase and frequency, right? And the DC components has no phase. There's a constant, right? It's just 1, right? Nice. So there's this thing. So now we could get it double-sided. So same steps. You have to invert. So this will be minus 4 f naught and minus 8 f naught. And we know the phases will invert, right? So this will end up being minus 180 degrees, right? And that's what I have here double-sided from the single-sided. Right, and with that said, that was the end of the question. Right, so nice.